Hello and welcome to Mike Academy. So in today's video, we're going to be looking at the second method of numerical methods, right? Now, the second method is actually a numerical technique which is used to approximate the root of an equation, usually of the form f of x equal to 0. So this method is quite easier compared to the Newton-Raphson's method in that in the Newton-Raphson's method, you have to perform a differentiation. So just in case you're not able to perform the differentiation, then the second method is an alternate method which is best to use as compared to the Newton-Raphson's method. Now by formula, you have it on the board, is given as xn plus 1 equals xn minus 1 multiplies f of xn minus xn multiplies f of xn minus 1 all divided by f of xn minus f of xn minus 1. Alright, so whenever a equation is given to you, just like we do in bisection method and in the Newton-Raphson's method, the first thing to do is identify two values or two numbers such that when you plug them into the function, it converts the function from positive directly into negative or from negative directly into positive. And when you do this, the smaller number of these two numbers is considered as x0, whereas the larger number is considered as x1. Now, what do I mean? Let's take this question on the board as an example. We are asked to find the root of the equation 3x cubed plus 2x minus 1 equal to 0, and we have to perform up to 4 iterations, right? So this means that this equation is actually of the form f of x, which is equal to 3x cubed plus 2x minus 1 equal to 0. So the equation is actually of the form f of x equals 0. So now, like I said, we need two values such that when we plug these two values into this function, it causes this function to change directly from positive into negative or from negative into positive. So we pick two values, right? So let's say, let's consider 0 first. Let's find f of 0. Let's pick 0. If you do this, you're going to have, which means anywhere you see x in this equation, plug in the value as 0. So I'll simply have 3 into 0 to the power of 3 plus 2 into 0 minus 1. So everything here simply gives us negative 1, right? Next, you pick 1. Okay, so let's pick when x is 1. So you simply find f of 1. So we find f of 1. This is going to be equal to 3 into 1 to the power of 3 plus 2 into 1 minus 1. So this value gives us 3 times 1 is 3 plus 2, that's 5 minus 1 is 4. So you actually have a positive value here plus 4. So now our root or our equation changes from negative directly into positive. That simply means the root of this equation lies between 1 and 4. Now, if you're able to get this, therefore, the least number among these two numbers is now considered as x0. So between 0 and 1, the least number is 0. So this simply means that my x0 is equal to 0. And the larger number is considered as x1. My x1 is equal to 1. Now, if you're able to get this, you fall back to your formula to perform your iteration. So for the first iteration, n is equal to 1. So for the first iteration, when n is equal to 1, that gives us our first iteration. So you look into the formula, wherever you see n now, you simply plug in the value as 1. I have xn plus 1 here. Since n is 1, it becomes 1 plus 1. So that gives me x2. x2 is going to be equal to, this is xn minus 1, and n is 1, so that becomes x1 minus 1. That simply gives me x0 multiplied by f of xn, so times f of xn. N is 1 there, so it becomes f of x1 minus, I have xn, n once again is 1, so that becomes x1 multiplied by f of xn minus 1. So n is 1, 1 minus 1 is 0, so you have f of x not the whole of this divides by, I have f of xn here, and once again n is 1, so that gives us f of x1 minus f of xn minus 1. So n is 1, it becomes 1 minus 1, which is 0. So you have f of x0. So you see that every value that we have in this formula, we have already found. We know the value of x0, we know the value of x1, we know the value of f of x1, we know the value of what? F of x0. So if you fall back to this equation, when n is equal to 0, we found f of 0 here. This f of 0 simply stands for what? F of x0. And when x is 1, that is when n is equal to 1, we found f of x1, right? So this here gives us f of x1. So everything we need from that equation is made available. We can simply now plug in the values into the equation to find the second root, x2. So x2 is now going to be equal to, what is x naught? We found x naught earlier to be what? 0. We said x naught is simply 0. So you have 0 multiplied by f of x1, and f of x1 gave us here positive 4. Okay, so you have 0 multiplied by 4 minus x1, and x1 is 1 from here. So minus x1, which is 1 multiplied by f of x naught, and f of x naught simply gave us negative 1 multiplied by negative 1. The whole of this divides by f of x1, and f of x1 is negative 1. Sorry, f of x1 is simply positive 4. So you have 4 minus f of x naught, and f of x naught is negative 1. Okay, negative 1. So minus 1. All right, so you have this. So let's evaluate everything. 0 times 4, of course, is 0. Minus 1 times minus 1 simply gives us positive 1, divides by 4 minus minus 1 becomes 4 plus 1. That simply gives us 5. So this simply implies that x2 is equal to 1 divided by 5. You can find the decimal equivalent of 1 all over 5. So 1 divides 5 simply gives us 0.2. So we found our second root, right? Now to perform the next iteration, that becomes when n is equal to 2. So for the second iteration, n is equal to 2. Now you do the same thing, plug this value of n now into the formula. Let's see what we're going to have, right? So if you plug into the formula, xn plus 1 here becomes x2 plus 1. That simply gives us x3. x3 equals, I have xn minus 1, that becomes x2 minus 1, which gives us x1 multiplied by f of xn, and n is 2. So multiply by f of x2 minus, I have xn, once again n is 2, so it becomes x2 multiplied by f of x, n minus 1, that's 2 minus 1 gives us 1, f of x1. The whole of this divides by f of xn, n is 2, so you have f of x2 minus f of xn minus 1, that gives us f of x1, and you have this. So we know what x1 is, we know what x2 is, so all we need to find now is f of x2, because we know what f of x1 is. So we simply plug in the value of x2 into the function to obtain f of x2, right? So we find f of x2, this is going to be equal to, into the function x2 there is 1 over 5, which is 0.2. So you have 3 into 0.2 to the power of 3 plus 2 into 0.2 minus 1. So let's punch everything together. So 0.2 to the power of 3 multiplies by 3 plus 0.2 multiplied by 2 minus 1. So everything here gives us negative 0.576. Okay, so f of x2 simply gives us negative 0.576. Now let's plug everything here to find the third root. Therefore, x3 equals, we know what x1 is. x1 equals 1. So that gives us 1 multiplied by f of x2. f of x2 gave us negative 0.576. So multiplies negative 0.576 minus x2. x2 here is 0.2. So minus 0.2 multiplies f of x1, and f of x1 simply gave us positive 4. So multiply by 4. Okay, the whole of this divides f of x2. f of x2 once again gave us negative 0.576. You have negative 0.576 minus f of x1. f of x1 simply gave us 4. So minus 4. This is going to be equal to, let's evaluate everything at the numerator. 1 times negative 0.576 minus 0.2 times 4 simply gives us negative 1.376 at the numerator. So we have negative 1.376 divides by, at the denominator, negative 0.576 minus 4 gives us negative 4.576. So let's evaluate negative 1.376 divides negative 4.576. So this simply implies that our third root, x3, equals 0.3007 approximately. So that gives us the value of the third root. Okay, so we are asked to perform up to 4 iterations. We've performed 2 iterations, remaining 2. Let's now move over to the remaining 2. So for the third iteration, that is when n is equal to 3. So for the third iteration, n is equal to 3. And if n is equal to 3, then the equation becomes n plus 1 there becomes 3 plus 1, which is x4. And that's going to be equal to, so basically the same thing, n minus 1 here becomes 3 minus 1, that's x2. We have x2 into f of x, f of x3 minus x3, okay, minus xn, of course, is x3 into f of xn minus 1, that's f of x2. F of x2 divides by f of x3, okay, minus f of x2. So basically the same stuff, right? So we have x2, we have f of x2 as well. All we need now is f of x3 because that's what we're lacking. So we can come here and find f of x3. So f of x3 is going to be equal to 3 in place of x. Let's plug in the value of x3, 0.3007. So we have 0.3007 to the power of 3 plus 2 into 0.3007 minus 1. So let's see what this value gives to us, right? Let's evaluate everything together. Everything gives us approximately negative 0.317. So f of x3 equals negative 0.317. Now let's plug into the formula. We're going to find the fourth root, x4, to be equal to x2. So x2, remember x2 from here, x2 is simply 0.2. So you fall back here, x2 is 0.2. You have 0.2 multiplies f of x3, and we just had f of x3 as negative 0.317 multiplies negative 0.317 minus x3, and we had x3 here as 0.3007. So you have 0.3007 multiplies f of x2, and f of x2 gave us negative 0.576 minus 0.576. Okay, the whole of this divides by f of x3. F of x3 gave us here negative 0.317, negative 0.317 minus f of x2. F of x2 gave us negative 0.576, negative 0.576, and you have this. So this means x4 is going to be equal to, let's evaluate everything at the numerator. So everything at the numerator simply gives us 0.1098 approximately. Divides by, let's evaluate the denominator. Everything at the denominator simply gives us 0.259. So let's find this ratio now. So that simply gives us 0.4239. So we have x4. Now, having found x4, we perform the fourth iteration, which is the final iteration, because the question says we should perform up to 4 iterations, right? So we perform the fourth iteration. So for the fourth iteration, that will be when n is equal to 4, right? So we can do that here. So for the fourth iteration, fourth iteration, we have n to be equal to 4. So we simply plug in n as 4 into this equation. So you already know how it works. N plus 1 becomes 5, right? So that gives us the fifth root. X5 is going to be equal to, so you have xn minus 1, that's 4 minus 1, which is x3, multiplied by f of xn, so f of x4, minus, you have xn multiplies xn minus f of xn minus 1. So xn is x4 multiplies f of x3 divides by f of x4 minus f of x3. So basically the same thing. So we have x3, we have f of x3. All we don't have here is f of x4, right? We also have x4. So we need to find f of x4, which is the value of the function when x is x4. So we had x4 here to be 0.4239. We simply plug the 0.4239 into the function to find f of x4, right? So this means that f of x4, okay, f of x4 is going to be equal to 3 multiplies 0.4239 to the power of 3 plus 2 multiplies 0.4239 minus 1. So let's try to find this value. F of x4 is going to be equal to, so f of x4 gives us approximately 0.0763. 0.0763. Okay. Or we can approximate to 0.076, since we've been working with 3 digits for the values of the function. Okay, so having found this, you simply plug into the equation. This is going to be equal to, we have x3, and the value of x3 from here is 0.3007. So that's 0.3007 multiplied by f of x4. F of x4 give us 0.076. So 0.076, okay, minus x4, which is 0.076. 0.076 multiplied by f of x3, and f of x3 gave us negative 0.317. Negative 0.317. The whole of this divides by f of x4, and f of x4 give us 0.076. 0.076 minus f of x3, which is negative 0.317. Negative 0.317. Okay, so this means x5 is now going to be equal to, let's evaluate everything at the numerator. So everything at the numerator simply gives us 0.0469 approximately, divides by, let's evaluate everything at the denominator. So everything at the denominator simply gives us 0.393. Let's find this ratio. So the ratio simply gives us 0.1193. You have 0.1193. So you can continue performing your iteration until the root of the equation converges. So the root of the equation will converge when, for instance, if x5 here was synonymous to x4, but as you can see, it hasn't converged yet, but the question says we should stop at 4 iterations. So to avoid the video to get too lengthy, we'll have to pause the method there. So that's how you employ the secant method of numerical method to approximate the root of a given equation. In the next video, I'm going to be coming up with more tedious examples as to how to employ this same method, secant method of numerical methods, to approximate the root of an equation. I'm sure you want to be a part of that video, so do well to smash the subscribe button right now and turn on your bell notification so you don't miss out on our next video when it drops. I will see you in the next video. Thanks.